morning everyone. Hope you all safe with a good health. With you, Ms. Dina Al-Badri, science teacher for grade 7. Today we will complete our lesson Earth's ocean and the ocean floor. How is the ocean floor started? To learn about the ocean floor, scientists use a technology called sonar. Sonar, it explains what happened beneath the water surface. Okay, so sonar, which stands for sound navigation and ranging, uses sound wave to measure distances. Sonar data can be used to make maps for the ocean floor. That you see here, the ships. These ships, it used sonar to study what happened inside the water surface. Satellites can measure variation in the height of the ocean surface. The ocean floor features can affect the height of the water above them. So, by using the sonar, we can study, we can measure the height of the water above the surface of the water. To explore the oceans, scientists use underwater vessels, some of which have pilots and researchers. Other vessels are remote operated. Using equipment on large ships, scientists can drill and collect cores or long tubes of the rocks and sediment from the seafloor. By the sonar technology, scientists can study the types, or if there is this place contain sediment, contain rocks or not. So it helps the scientists. By using the equipment on large ships, scientists can drill and collect cores or long tubes of rocks and sediment from the seafloor. So here, did you see? They use satellite, using sonar, using navigation to studying the deeps of the ocean floor or the underwater. What are the two main regions of the ocean floor? The two main regions of the ocean floor are the continental margin and the deep ocean basin. So we have two places on the ocean floor. First one we call it continental margin, and then the other one we call it deep ocean basin. The continental margin is the edge of the continent that is covered by the ocean. So it is the edge, like the boundaries. Did you see? It is the edge of the continent that covered by the ocean. The continental margin is divided into the continental shelf and the continental slope and the continental rise. So continental margin can be classified into continental shelf, continental slope, and continental rise. When someone asks me what the difference between them, they are the three types of the continental margin. What is the continental margin? It's the edge of the continent that is covered by the ocean. The second region in the ocean floor, the deep ocean basin, begin at the end of the continental margin and extend under the depth part of the ocean. Like when I have two parts, the upper part we called it, continental margin, and the second part, the deepest one, we called it deep ocean basin. The deep ocean basin includes narrow depressions and flat, smooth plains. Along undersea mountain chain that along the floor of the ocean is called a mid-ocean ridges. So when we said what are the two types or the two regions of the ocean floor, we will say the first one is continental margin. The second one, the deep ocean basin. We say that along the undersea mountain chain that form along the floor of the ocean, we called it mid-ocean ridge. Mid-ocean ridges occurs at the boundaries of the Earth's tectonic plates, where the plates move apart from each other. This motion creates a crack in the ocean floor called the rift. The motion creates a crack in the ocean floor called the rift, allowing hot magma to move upward. So this movement inside the water, sometimes it make a volcano. It helps the magma to go outside the earth. to move upward through the rift and cool to form new rock. The large, flat, almost level area of the deep ocean basin is called aphusal plain. This area is covered with layers of fine sediment. Allowing a narrow depression in the deep ocean basin is called an ocean trunk. It forms where one tectonic plate subducts another plate. Volcanoes and earthquakes are common in and along subduction zones. Okay, that's all. But to understand this part, we have to watch a video. This video is talking about the ocean floor, the two regions in the ocean floors, and a small prep for each one. You have to watch the video to understand this part very good. Okay, hope you all understand. If you want to write the answer of this question, identify the various features of the ocean floor, or draw it, or print this part and solve on it as you want, and present it at alwaha@americansciencehomework@gmail.com. Please watch the video carefully. Thank you.
Ocean floor features. When you imagine the ocean floor, what does it look like? You may be surprised to learn that the bottom of the ocean is a dynamic place with higher mountains and deeper valleys than any found on land. It is a mysterious place too. Some parts of the ocean never receive sunlight, and the pressure of the water is greater than several jumbo jets on top of your body. With such hostile conditions, how do scientists even know what the ocean floor is like? In some ways, gathering information about the ocean floor is similar to learning about space. Sometimes people can travel to the ocean floor in vessels specialized to protect them from the pressure and cold. Just like space, however, many missions are unmanned. Scientists can indirectly determine information about the ocean floor, just like how they use radio and infrared telescopes to observe the sky. One method of indirectly collecting data about the ocean floor involves using sound waves. By reflecting sound off the bottom of the ocean, scientists can map the topography or shape of the ocean floor. If sound waves are sent deeper into the ocean floor, scientists can even learn about its composition. Plate tectonics work to continuously change the topography of the ocean. Just like the plate movement below land masses, the changes may be slow, but they are responsible for the mountains and trenches that comprise the dramatic landscape deep under the water. Earthquakes may even happen underwater, resulting in a giant wave called a tsunami. Divergent boundaries are one example of how plates move in relation to one another. When two ocean plates move away from one another at a divergent plate boundary, magma rises up to create a ridge. The deep crack created in the center of the ridge is called a rift valley. A deep trench is formed where an oceanic plate moves under a continental plate at a subduction zone. At more than 10,800 meters, the Mariana Trench is about 2 kilometers deeper than the height of Mount Everest. Volcanoes also form at subduction zones. When the plate that is pushed downward melts, the magma may rise up to the surface. Volcanoes may also form away from plate boundaries at hotspots. Hotspots are locations where magma rises up through a crack in the crust and reaches the surface. Initially, this forms an underwater mountain called a seamount. The Hawaiian Islands are an example of a series of volcanoes that formed over a hotspot and became large enough to reach above the surface of the water. Some volcanoes may evolve into a guyot over time. Guyots are unique because of their flattened tops. These structures start as seamounts, but after their tops reach the surface of the ocean, they are eroded away. This erosion gives guyots their characteristic appearance. So far, you have learned about some of the features that result from the actions of plate tectonics. But what about the regions of the ocean where not as much happens? Let's start by going for a swim. The portion of the continent that is underwater is called the continental shelf. When you wade out into the ocean, you are standing on the continental shelf. At the edge of the continental shelf, a sudden increase occurs in the depth. This marks the beginning of the continental slope. Once the rate of descent decreases again, the continental rise begins. Although the name might seem to imply it, the ocean does not become shallower here, but it does not become deeper as quickly either. Finally, at the end of the continental rise is the abyssal plain. This large, flat region is the site of sediment buildup and extends to the underwater ridge or a volcano. Although most of us will only see a small portion of the ocean, it is a fascinating place with many mysteries still awaiting to be discovered.